Assalamu alaikum, dear brothers. In this video, I'm going to explain how to draw the graph for your physics lab experiments. Okay, so please listen carefully. And this video is recorded and it should be saved in your Blackboard. And you can access this video at any time. And please have a look. If you have any doubts, please feel free to ask me. Okay, so I'm going to open the slides. So here I'm going to explain the graph for your second experiment of physics 1. The second experiment title is uniformly accelerated motion. Okay, so in this experiment, what we are going to do, we are going to find the value of G. We know the value of G is 9.8 meter per second square. So after you finish drawing the graph, after you calculate the slope, after you finish the data analysis, your value of G is closer to 9.81. So if you just see this experiment paper, each experiment has the main equation. So here the main equation of this experiment is this one, x2 minus x1, which is equal to half G sine theta t square. So if you just see this equation, x2 minus x1, theta and t square are the main important parameter for calculating the value of G. So here you have two data table. In the first data table, you are going to find the value of theta. In the second data table, you are going to find the value of x2 minus x1 and t square. So after you fix the value, after you recorded the value in this data table, you are going to draw the graph from this value. So that means the second table is very, very important for drawing the graph. My dear, in each experiment, we will give this information. What is written here? Draw the graph of x2 minus x1 versus t square. So if you take the second experiment or third experiment, so whatever the experiments you have the graph, this information must be there. So what it exactly says? This versus this. That means x2 minus x1 versus t square. That means the first parameter is your y-axis parameter, and then the second parameter is your x-axis parameter. That means x2 minus x1. If you just see the second table, you can see here you have x2 minus x1, here you have t squared. That means you are going to take all these values in your y-axis and you are going to fix all these values in your x-axis. Clear? Clear, my dear? So please don't do this mistake, because many students in the exam, they draw the axis in the reverse way. So please read this information, draw the graph, and please draw the graph of this versus that. That means the first part is exactly says about the y-axis. The second part says something about the x-axis. So you have to take all your x2 minus x1 in your y-axis and then the t square value in your x-axis. So now you can see here, after you find the value of G by using this equation, you have to find the error percentage, because the value of G is 9.81. Suppose if your value of G is 10.3 something. So you have to find what should be the error percentage difference between your answer and the actual answer. Clear? So if you just see how to rearrange this equation, first of all, you must know how to rearrange this equation. In the exam, for rearrangement of the equation, we give 1 mark. So please listen carefully here, x2 minus x1, which is equal to half G sine theta t square. That means you are going to rearrange this equation in terms of G. So what you will get, you can just write G, which is equal to 2 multiplied by x2 minus x1 divided by sine theta multiplied by t square. So you have to rearrange these things, and then here the x2 minus x1 over t square, I think you are going to get the information from the graph. After you fix the value of x2 minus x1 in the y-axis and t square in the x-axis, you have to find the slope, and your slope is nothing but this x2 minus x1 over t square. I will explain after we draw the graph. Clear? So by using this equation, you have to find the value of G. Clear? And then you can see here, okay, x2 minus x1 over t square is your slope, and theta, you can see here, the theta is also the important parameter. So you have to take the theta from the first table. I will teach you, inshallah, once you come for the lab. So when we are about to start this experiment in the lab, I will teach you how to find the value of theta. Clear? So here, this paper is a student paper of last semester. So just for the explanation purpose, I am using his data for in this video. Okay. So please, my dear, listen carefully. Here, I take the graph in the landscape format. If you want to use the graph in such a way, in this position, no issue. Or if you want to use the graph sheet like the portrait form, no issue. So here, for the explanation purpose, I am just using the graph sheet in the landscape. So the first step of drawing the graph, once you take the graph, you have to sharpen the pencil. You have to use only the pencil in the graph. You should not use the pen. So please listen carefully, make your pencil sharp, and then please use the ruler. The ruler is very, very important because most of the students, they never use the sharp pencil. So please, my dear, it's my kind advice to each and everyone who saw this video. Please listen carefully. You have to use the sharp pencil. So the first step of drawing the graph, you have to take the graph paper, and then first you have to draw the x-axis line and y-axis line. Before that, we saw what is your x-axis value. Your x-axis value is t square and your y-axis value is x2 minus x1. So first you draw the line for y-axis. So this is the line for y-axis. Am I right? So I can just write this is my y, and I have to write this is 1, this is my x. Am I right? And then we have to write what you are going to take in the y-axis. What we are going to take? We are going to take x2 minus x1, and then we are going to write the unit. The unit is very, very important. If you forget to write the unit, marks will be deducted from the total mark. And then what you are going to take in the x-axis? We are going to take t square. So t square, I have to write the unit for t square is secant square. This is your first step. Once you take the graph paper, you have to draw a straight line. My dear, you have to draw the straight line. So please use the sharp pencil and a ruler. And now what you have to do, you have to see the values. If you just see your y-axis value, so these are all your y-axis, am I right? And these are all your x-axis. Your y-axis is already in the regular interval. It's very easy to fix. But if you just see your x-axis, it's not a regular interval value. That means what is the meaning for regular interval? If you subtract this 0.8 with this 0.61, you will get some value. That means that value should not be same for each difference. Am I right? So what you have to do, initially you have to see what is your lowest value and the highest value. Here my lowest value is 0.61, my highest value is 1.60. So what I'm going to do, I'm going to take the regular interval. What is my regular interval? When you take the difference of two numbers, that number should be the same for the remaining other numbers. So you can just see here, this is my origin. So I'm going to take here 0.25. Likewise, after two box, I'm going to take 0.5. Here 0.75. Here 1.25. Here 1.5, 1.75, 2. So if you just see the value of x, my value started from 0.6 to 1.6. So you can fix this value in between these numbers. Am I right? Am I right or not? 0.6 will come here, 0.6 will come here, and then your 1.6 will be ended here. Am I right? So that means within this interval, you can fix all the values of your x-axis. Now, what is meant by regular interval? You can see here, my dear, what is the difference between these two numbers? If you just subtract 0.5 with 0.25, you will get 0.25. So the difference between these two is 0.25. Likewise, the difference between these two is 0.25. The difference between these two will be 0.25. This will be 0.25. That means my x-axis interval is 0.25. So you have to follow the regular interval. Suppose, doctor, I want to take 0.2, 0.4, 0.6, no issue. So while you take the value of x-axis and y-axis, you have to follow the regular interval. You can choose any number, but that number should be regular interval. You can see here, I just write the value in terms of 0.25. Suppose if you want to write the value in terms of 0.2, no issue. What is your regular interval? If you take 0.2, your 0.2, 0.4, 0.6, your regular interval will be 0.2. Clear? So for my case, for this explanation, I took 0.25 as my regular interval for my x-axis. Likewise, I have to see the y-axis value. My y-axis value exactly started from 45 to 105. That means what I'm going to do, I'm going to exactly start from 40. So 40, I'm going to take 50 here, 60, 70, this one 80, 90, 100, and 110. Now you can see your values of your y-axis exactly from 45 to 105. You can fix it here. Am I right? Am I right or not? Now you can see your y-axis interval. What is your y-axis interval? My y-axis interval is exactly 10. You can see here 50 minus 40, 10, 60 minus 50, 10, 70 minus 60, 10, 80 minus 70, 10. So if you just see all the values of your y-axis, the regular interval of the y-axis, we take it here as 10. The second step, you have to see the number of boxes. My dear, the most important thing, why we are using the graph sheet? Because if you are using the graph sheet, you can easily locate the point perfectly on the box. Here, each box tells you the some location. For example, you can see one box. I actually here I pasted this graph sheet. It's not that much clear, but if you take the graph sheet, for example, you can see this box. You can see this box. This is my one box. Am I right? If you see this box, inside the box there are 10 horizontal small. In the horizontal line, you have 10 small boxes. That means you can see here. Here you have 10 small boxes there horizontally, and then 10 small boxes vertically. Am I right? So each and every small box is 1 millimeter. So if you take one box in the graph, the value of one box is 1 centimeter. Inside that one box, you have small box 10 horizontally and small box vertically, and each small box carries the value of 1 millimeter. So 10 millimeter forms you 1 centimeter. Clear? Clear, my dear? So now what you are going to do, once you know what is your interval, now for this interval, how many boxes you are taking? So here, this box is considered as one big box. So likewise here, how many big boxes you take it for this 0.25? 2 boxes. You can see here, from here to, that means from the intersection, that means origin to here, we took 2 boxes. That means we took 2 boxes for this 0.25, 2 big boxes. And in these 2 big boxes, I told you just before, in one boxes you have 10 small boxes. So if you take 2 boxes, what should be the total number of small boxes? The total number of small boxes is 20. 20 small boxes. So in this graph, for this graph, I choose 0.25 as my regular interval for the points, and then for this 0.25, I choose 2 big boxes, and in these 2 big boxes, I have 20 small boxes. Likewise, let's we just see for the y-axis. Here, my regular interval is 10, and then for this 10, again, I took 2 boxes. So that means for this 10 also, I took 2 big boxes. And then in these 2 big boxes, how many small boxes? Again, 20 small boxes. 20 small boxes. Now, if you want to know what is the value of one small big, because you can see here, we have 20 boxes, am I right? So if you have 20 boxes, you must know what should be the value of one small box. So in x-axis, the value of one small box, here you can see here, the value of one small box, we have to know the value of one small box as, what you have to do, you have to take the interval, you have to divide that interval by 20 small boxes. So here we take 20 boxes. Suppose if you take 3 boxes, so you have to divide the interval by 30. So in this case, in this graph, we take 20 boxes. So my interval is 0.25. So 0.25 divided by the number of boxes, which is equal to 0.0125. So this is the value of one small box in x-axis. Likewise in y-axis, my interval is, what is my interval? What is my interval, my dear? My interval is 10. Am I right? So 10 divided by 20. So the value of one small box in y-axis is 0.5. So once you know the value of small boxes, you can easily find the location of these points in the graph sheet. For example, first I'm going to take the value of x-axis as 0.61. So what I'm going to do, I'm going to fix this 0.61 and 45. So what I'm going to do, I'm going to write 0.61 here. What I'm going to do, I'm going to write 0.61 because I'm going to fix this point 0.61. Now once you just know the first value, you have to see this value, where this value exactly coming from. You can fix this 0.61 only between these two numbers. So this 0.61 is between 0.5 and 0.75. So if this value is between these things, what is the lowest value here? 0.5. So what you have to do, write that number minus, you can see the graph, that small value is here 0.5 because 0.61 is between these two values, and that small value, because between these two numbers, that means the lowest value of these two numbers is 0.5. So I have to subtract 0.61 with 0.5 divided by the value of one small box. What is the value of one small box? 0.0125. So you have to use your calculator for the calculation. So I'm going to divide 0.61 minus 0.5 divided by 0.0125. So if you just work out, I got 8.8. My dear, after the decimal, if the value is 5 and greater than 5, you can round at that number. For example, here I got 8.8, so I can round at this number as 9. So what is this 9? The 9 indicates the small box value. From where? From 0.5, because we took 0.5 as the smallest value. From this box, from this point, I have to choose 9 small boxes. That means where your 0.61 is exactly coming, you can fix this value here. From 0.5, you have to take 9 boxes. That 9th box indicates your 0.61. For example, you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means this is my 0.61. Clear? And then what is your y-axis? My y-axis is 45. Am I right? 45. So your 45 is between 40 and 50. So what is the lowest value? 40. So 45 minus 40 divided by, what is the value of one small box? The value of one small box is 0.5. So when you just work out with your calculator, you'll get 10. That means from 40, 10 boxes. That means this is your 45. Now you have to fix the intersection. So my 0.61 is here, my 45 is here. So when you just fix the intersection point, the intersection point of these two will be here. Am I right? So this is my first point, first set point. Clear? Let's go for the second set. What is your second set? 0.8 and 55. So 0.8. So where is your 0.8 exactly coming? It will be there. It will be between 0.75 and 1. Am I right? Your 0.8 is between 0.75 and 1. So what is the lowest value? 0.75. So 0.8 I am going to fix. 0.8 I am going to fix. And your 0.8 is between 0.75 and 1. So the lowest value is 0.75. So 0.75. And the value of one small box in the x-axis is 0.0125. When you just calculate with your calculator, so 0.8 minus 0.75 divided by 0.0125. I got 4. That means 4 small boxes from 0.75. That means it will come here 1, 2, 3, 4. Am I right? Am I right or not? So this will be the value of 0.8. And then the corresponding y-axis for this 0.8 is 55. 55. Again, 55 is between 50 and 60. The lowest value here is 50. So 55 minus 50 divided by the value of one small box. Again, it will be give 10. So your 55 will come here. So now if I want to fix the intersection point here, so I got this point as my intersection point. Am I right? Clear? Let's go for one more point. What is our third point? 0.95 and 65. So 0.95. Where is your 0.95? Your 0.95 is between 0.75 and 1. So the lowest value between these two is 0.75. So 0.95 minus 0.75. The value of one small box is 0.0125. And I'm going to calculate this. So 0.95 minus 0.75 divided by 0.0125. I got 16. That means 16 small boxes from 0.75. So 16 small boxes. That means from this is 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this will be my 0.95 value. Am I right? Am I right or not? So from here to here, 16 boxes. So again, the corresponding y-axis value is 65. So 65 is between 60 and 70. The lowest is 60. So 65 minus 60 divided by the value of one small box is 5. So I got 10. So that means this is my 65 value. Now I am going to fix the intersection point. So it will come here. Clear? So likewise, you have to do the rest by using the same method. So when you use the same method, the remaining points will be fixed and it will be coming like this. So it will be gradually increasing. Am I right? Am I right or not? So now what I'm going to do, I'm not going to fix the remaining point. So you have to do by yourself. And for these 3 points, I'm going to draw the straight line. So once you fix all the points, what you have to do, you have to connect this point with a straight line by using your ruler. Okay. So don't use your hand just for making a line. You have to take your sharp pencil and you have to take your ruler and then you have to make a straight line. That straight line should connect all the points. How many points will be coming? You have to connect all the points with the straight line. So now you can see here for these 3 points, I'm going to, because I don't have the ruler. So what I'm going to do, I'm going to fix this. It will come like this. Now what I'm going to do, I'm going to choose the first point and the second point because these first point and the second points are exactly on the line. So I'm going to draw the slope diagram. My dear, you have to draw this slope diagram. You have to draw this slope diagram. If you don't draw the slope diagram, I will deduct some mark. So I must know which point you choose for the slope calculation. Okay. So what you have to do, you have to choose these 2 points. Why my line is like this? Change. Okay, so this is my point slope diagram. Now what you have to do, you have to find the slope calculation. So what I'm going to change the color of the ink by that you will get some idea. So what is my x1 value? So this is my x1 value, this is my x2 value, this is my y1 value, this is my y2 value. So here you have to choose 2 points and that point must be on the line. Now you know the slope calculation formula. What is the formula for the slope calculation? You already studied in your school. Slope calculation formula is slope which is equal to delta y over delta x. Now you can see in y-axis what you take, my friend. What you take in y-axis? In y-axis you take x2 minus x1. So I can write x2 minus x1 here. In the x-axis what you take? You took t square. So now delta y is nothing but y2 minus y1. Delta x is nothing but x2 minus x1. So what is the value of y2 here? My y2 value is 55. My x2, my y1 value is 45. My x2 value is 0.8. My x1 value is 0.61. Now please calculate the value of slope. 55 minus 45 divided by 0.8 minus 0.61. So you got 52.63. 52.63. But the unit is very, very important. For y-axis, what is the unit? Centimeter. Am I right? For x-axis, what's the unit? T square. That means second square. Now this is in centimeter over second square. You have to convert this centimeter to meter square. So sorry, centimeter to meter. How to convert this centimeter to meter? If you divide this number by 100, you will get the answer in terms of meter. Am I right? So if you divide, what you will get? 0.5263 meter per second square. Am I right? Now you can see my slope, which is equal to x2 minus x1 over t square. Am I right? Because why? Because in y-axis we take x2 minus x1. In x-axis we took t square. But the slope formula is y2 minus y1 over x2 minus x1. Now, once you find the slope, what you have to do? You have to use this equation. You have to use this equation for the calculation of g. So I'm going to write this equation again. So x2 minus x1, which is equal to half g sine theta t square. I'm going to rearrange this equation in terms of g. Therefore, g, which is equal to 2 multiplied by x2 minus x1 over sine theta multiplied by t square. So this x2 minus x1 over t square is your slope. Is your slope. Your slope is 0.5263. Am I right? And what is your theta? Your theta value is exactly from the first table. So our theta value here, the student, he found 6.459. 6.459. So I'm going to substitute the value. Therefore, my g, which is equal to 2 multiplied by slope divided by sine theta. Now I am going to substitute the value. 2 multiplied by my slope value is 0.5263. 0.5263 divided by sine of my theta value is 6.459. 6.459. Now you have to use your calculator for finding the experiment value of g, because you find this value. That's what we are saying, this g as the experiment value. So what you'll get? 2 multiplied by 0.5263 divided by sine of 6.459. So I got 9.357. So 9.357, I can write 9.36 meter per second square. What's the actual value of g? The actual value of g is 9.81 meter per second square. And what is the experiment value of g? You got 9.36. So now, once you find the value, what you have to do, you have to find the error percentage of your experiment g with the actual g. So you have to use this formula. You have to use this formula. So what you will get? Error percentage, which is equal to absolute value of g experiment. What is your g experiment? 9.36. Am I right? 9.36 minus what is your actual g? 9.81 divided by actual g, 9.81 multiplied by 100. Now, my dear, this is absolute value, because when you subtract this 9.36 with the 9.81, you will get negative value. Once you have negative, you can consider only the absolute value. So I'm going to use the calculator. So what you'll get? 9.36 minus 9.81 divided by 9.81 multiplied by 100. So what I got? I got minus 4.59. So I can just take only the absolute value, 4.59% error. My dear, when you are about to calculate this error percentage, your error percentage must be between 0 to 20%. If your error percentage is greater than 20%, that means you did some mistake while you record the value in this table. So please, while you do the calculation, while you record the value, not calculation, while you record the value, that means while you are handling the apparatus, while you are using the apparatus, please record the value very carefully. If you made any mistake in the x2 minus x1 and t square and the theta, then finally your answer will not be closer to 9.81. It will be more, or sometimes it will be too less. So please do it very carefully. So if your answer of the error percentage is between 0 to 20%, quite enough. We will consider. We will give full mark, because no one will get exactly 9.81 while you do, because we have some errors. We have the air resistance, and sometimes you did mistake some while you carried out the while you are just handling the apparatus. So in such a case, you have some errors. So that error is nothing but small quantity. Am I right? Small amount. So when you are about to calculate the error percentage, it should be between 0.20 to 20%. But if you just see this data, we got only 4.59 error percentage. So it will be quite good. So we can consider this answer. Clear? Clear, my dear? So in such a way, you have to draw the graph. So please listen carefully. Just have a look of this video. If you have any doubts, please feel free to ask me. Clear? Understand? So you can follow the same method for the rest of the experiments. If you follow this method, you can avoid the mistakes, because if you made any mistakes in your slope calculation, it will affect your final answer. So please draw your graph perfectly. Once your graph is correct, then the rest of the things will be correct. If you made any mistake in the graph, the rest of the things will be totally wrong. So please listen carefully, my friend, and then please feel free to ask if you have any doubts. Okay, that's it. Thank you so much.